Hi guys, I cannot believe that it is almost the end of the school year. We're going to be in June in 1 week. It's crazy. Anyway, we only have a few more topics to cover in this course, and we're going to do this first section of Chapter 5, very much related to what we just finished in Chapter 4. Here we're going to now write equations of lines instead of using equations of lines to graph. We're going to be going in reverse. As always, YouTube channel Ms. Jackson Math Teacher, and the objectives of this section is to write the equation of a line in the following different scenarios. The first one is when given the slope and the y-intercept of the line. That's the easiest one to use. The second is identifying the slope and y-intercept visually from a graph. The third is when given the slope in one location of a point on the line, in other words, an ordered pair, write the equation. And then finally, the only thing you're given is 2 points on the line, and we're given 2 ordered pairs of their location. Okay, let's quick review some vocabulary. Of course, slope, we've been talking about that for a while now. Slope is represented by the letter M, and it is the rise over the run. And let's go ahead and remember that the rise is going up and down. That's change in the y direction. And the run is the change in the x direction. So let's also write that. If you have 2 ordered pairs, we can say that the rise is the difference between the y coordinates, and the run is the difference between the x coordinates. And of course that would be given we have x1 comma y1 and x2 comma y2. We have 2 points. Okay, what is the y-intercept? Well, the y-intercept is where, again, a line crosses that y-axis, that point location. So it is where a linear function crosses or intersects, I'm going to say crosses, the y-axis. And the slope y-intercept form of a linear equation is y equals mx plus b. And that m is just a coefficient, and that is the slope. We might as well remember that's a coefficient. It's just a pure number sitting in front of that x term. And that's only in the case where y is all by itself. We cannot have anything around y. When we solve a function for y and it's all by itself, then this number right in front of the x is a slope. The x is not part of the slope, so I still continue to hear some people say, in other words, I'll just make a random example here, y equals 2x plus 1. I still hear people say that the slope is 2x. The slope is not 2x. The slope is 2. It's just a pure constant number. Okay, and then this plus b here is just a placeholder also for a number, and that is the y-intercept. And of course, that's the y-intercept because the y-intercept happens when x equals 0. Right on this y-axis, x is not positive, x is not negative, x is 0. And so if we put x in here for 0, that term would just go away, and therefore that is our y-intercept. And ordered pair. The ordered pair is an x and y coordinate together, and they indicate the location in the x dimension and the y dimension of a point. So that is a point on the line. For instance, if we had 1 here and 3 here, this particular point A, let's call it, we would call x comma y, and that location would be 1 comma 3. That is an ordered pair, 1 comma 3, pair of numbers that represents the location. All right, let's start the first method. Write the equation of a line when given the slope and the y-intercept. Well, this is easy peasy, really. We know that the equation of a line, is y equals mx plus b. We know m stands for the slope, so I'm going to swap out m, and I'm going to put here the slope I've been given is 2/3 times x, And the y-intercept is -2. So I could add a -2 here. I have to separate this addition with this sign, but it's easier to just write it y equals 2/3 x minus 2. As you know, adding a -2 is the same thing as subtracting 2. All right, next example. Example 2, we have a slope here of -4 and a y-intercept is 3/2. Well, again, y equals mx plus b. We're going to swap in our slope, m, which is -4, and our y-intercept is a positive 3/2. Or if you wanted to, you could rewrite that as a decimal, 1.5, 1 5/10. So this would be our final equation in slope y-intercept form. Good. Let's now try method 2. Method 2 is writing the equation of a line when given a graph. Okay, so here in our very first example, points have been identified for us. So we have A right here and B here. Well, right there is the y-intercept, and that's represented by B in the equation that we use. And you can see here that y equals 3. Now we need to find the slope. Well, in between, we've already been given some points here. The rise down, you see, our guy here, remember, would be walking downhill. And so the rise is negative, and we just count the boxes. 1, 2, 3, 4. So the rise is a -4. And the run in between our 2 points is only 1 box. So slope rise over run is going to be -4 over 1. We know our equation of a line in slope y-intercept format is y equals mx plus b. Therefore, we're going to substitute in our slope. You can put -4 over 1, or you could just put -4. And our y-intercept is positive 3. Now on this example to the right, example 2, you can see no points have been noted for us. So we have to identify some points, and the way we do that is we look along the line and try to see where the line is crossing right on the grid. So you can see here our line happens to be going right through the origin. Remember, we might as well write that down. The origin, that means our y-intercept B equals 0. Okay, and now we have to keep going up that line. So travel up the line and see where the line crosses right on the grid. And I see the first place it does so is right there. So I'm going to mark that point. And now I've got to get the rise. And our slope is positive because we are climbing uphill. And the rise between those 2 points, count the boxes, is 1, 2, 3, 4. So the rise equals 4, and the run in between those 2 points is 3 boxes. So therefore, our slope, rise over the run, equals 4/3, positive 4/3. And the slope, or sorry, the equation of the line is y equals mx plus b. And we're going to bring it all together now. Y equals, our slope is 4/3 times x, and plus b. You could put plus 0 here if you wanted to, or you could just leave it off. Now let's take a look at example 3. Example 3 is a flat line. If you recall, the slope here of a flat line is 0. And why is it 0? Well, it has no rise. So the rise is flat, it's 0, and the run is infinite because all lines actually go on and on forever. So they would go right off the graph. 0 divided by anything is 0. So we have no slope whatsoever. So if we take a look at the equation of a line, y equals mx plus b. If we substitute in 0 here for our slope times x, well, that whole thing just goes away. 0 times anything is 0. So we just have y equals b, and we look to see what that y-intercept is, and here it is -2. So in this case, y equals -2. We have no x term, so this is the equation of our line, y equals -2. And similarly, over here on example 4, we have a vertical line going straight up and down. Well, if you recall, our slope here is undefined. And why is that? Because the slope is rise over the run, and our slope rise is infinite, going on and on forever right off the graph. And the run, there is no run. There's no change in the x dimension. So we're dividing by 0, therefore that slope is undefined. Now how do we deal with this in an equation sense? Well, y equals mx plus b, we really can't have an undefined slope. So this equation is really not going to work. What we do have, though, is an x-intercept, not a y-intercept. We're not crossing the y-axis at all on this vertical line, but we do have an x-intercept, and the x-intercept equals 4. And if you look here, everywhere on this line, x equals 4. At every one of those points, in fact, there's an infinite amount of points there. And so we represent the equation of a vertical line as x equals, and whatever that x-intercept is, in this case it's +4. So the equation of our line here on a vertical line will have no y in it. It will only have an x term. Okay. At our method number 3. Method number 3 is write the equation of a line when given the slope and one point that's located on the line. And we, of course, describe the location of that point given an ordered pair. Okay, so in our first example here, we have the slope is -4, and it passes through this point A's location. Y equals mx plus b. It's a plus sign. Y equals, well, we know what the slope is, so we might as well put it in. What we don't know is what the y-intercept is. We have no idea what this is, and we don't even have a graph. But what we do know is that this -2 over here is x, and the 5 is y. So we're going to substitute those into our equation and then solve or calculate the y-intercept. So here we have, I'm going to rewrite it, y equals -4x plus b. I'm going to replace that y with one value that I know is on the line, which is 5, and -4, and I know the x there is -2 from that point. And so now I'm down to one variable, the y-intercept. So 5 equals -4 times a -2 is +8 plus b. I'm going to rewrite that up here, guys. Now I want to solve for b. We'll go to the unknown, go directly to the unknown, look what's around it, and undo those operations. So here we're adding 8. So to undo add, I'm going to subtract 8. And whatever I do on one side, I got to do on the other. So I have b equals 5 minus 8 is -3. So now I'm going to bring everything all together now. Y equals -4x, because our slope is -4, and our y-intercept is a -3. So I'm going to subtract 3, which is really the same thing, of course, as adding a -3. And that would be the equation of this line. Example 2, we have a slope of 3, and it goes through this point A. So start again, y equals mx plus b, and put in what we know. We know the slope is 3, so we're going to swap out m and put in its value here. Now we have to solve for the y-intercept. Well, here, this is y and this is x. We're going to substitute them in. So -2 is in for y, 3 times 3.5 in for x, and we are going to solve for b. Now we've got to simplify things here. 3 times 3.5. Well, I don't happen to know that off the top of my head, so I'm going to do some long multiplication. 3 times 5 is 15. I've got to carry that 1 over there. 3 times 3 is 9, plus 1 is 10. Now I have one decimal place here, so I move this right over in here. I start from the right and I move that right in there. So 3.5 times 3 is 10.5, or 10 and 5 tenths. So I've got 10 and 5 tenths plus b. Go to the unknown, go directly to the unknown. Look what's around that unknown b. We're adding 10.5, or 10 and 5 tenths. So we've got to undo that with subtraction. And I'm sorry, this got a little messy. So that's going to cancel. And what we have here is b equals, now we've got -2 minus 10.5. Same sign. So we're going to end up with -12 and 5 tenths here. We add the numbers, keep the sign. Now to bring it all together, we've got y equals 3 for our slope, and our y-intercept is -12.5. And that is our equation. Example 3, we've got a slope of 2/5. Hopefully you can still see that under my writing here. And a line that goes through point A located at 10, -3. So start again. Y equals mx plus b. Write what you know. Y equals 2/5 x plus b. Now we're going to substitute in our x and our y here, x and y. So I've got y, whoops, I'm going to put in -3 for y equals 2/5, and I'm going to substitute in 10 for x, and then we're going to solve for b. I've got -3. We can simplify this here. This is 2/5 times 10 over 1. I can multiply the tops, that would be 20, divided by the bottoms, which would be 5. So hopefully you can see that 10 divided by 5, well, we might as well do this. 20 over 5 plus b, -3 equals 20 divided by 5 is 4 plus b. Go to the unknown, go directly to the unknown, look what's around it, undo. So I've got add 4, so I'm going to subtract 4. And we have b equals -3 minus 4. You're going even more negative, -7. Now I'm going to bring it all together. Y equals mx plus b. We've got 2/5 for m. That's a 5, by the way. Sorry about that mess. And we are subtracting 7 for our y-intercept. So that's the equation of our line. And finally, the last set of problems, write the equation of a line when given 2 points on the line. So in this case, we're not even given the slope. All we're given is that point A and point B are on that line. Now we could certainly graph these if we wanted to, but I don't have any graph paper here on the note, so I want to show you how to calculate things. So first things first, we want the slope. We know that the slope is rise over the run, and we know that that is the change in the y-coordinates over the change in the x-coordinates. So substitute, that's x1, x2, not x2, it's y2, y1, y1, x2, and y2. Excuse me. Okay, so here we go. We've got 4 for y2 minus 5 for y1. And if I started over here with this pair, I've got to go right back here to this x2. So I've got -1 minus, don't forget we're minusing a negative number. So 4 minus 5 is -1. 1 minus a -2 is, -1 minus a -2 is -1 plus 2. So this is -1 over 1, which is just -1. So y equals mx plus b. I'm going to substitute in that slope. Y equals -1 x plus b. Now you're going to repeat the same steps that we did above. We're going to solve for the y-intercept. Now you might ask yourself, well, what point do I substitute in, point A or point B into this equation? Well, it doesn't matter. Both of those points are on the line. So you could even try using both and see if you get the same y-intercept. You should, if you do everything correctly. Okay, I'm just going to go ahead and choose point A. And for point A, I have 5 for y, so I'm going to replace y with 5 equals -1, and I'm going to multiply that by a -2 for x, which is what we have here. By the way, you can't swap. You have to choose one point only. And I'm going to solve for b. So I have 5 equals, well, -1 times a -2 is a +2. Plus b, go to the unknown, go directly to the unknown, look what's around it and undo it. And I have b equals +3. So I'm going to bring that all together now, and I'm going to say y equals mx plus b. Our m we found to be -1, and our y-intercept is +3. I'm going to go ahead and end this video now just to make sure that it's not too long, and we will do example 2 and example 3 together in class as a warm-up. Thanks for listening. Please subscribe. Take care.